Okay, here we go with question 5. We've got 3 people, they're all cyclists, they're doing time trials every Sunday. We've got independent probabilities, and we've got these 3 probabilities here. And the first thing we've got to work out the probability of none takes part. So that's a probability that each one takes part. So to get the probability none does, we need the first one not to take part, and then we need the second one not to take part. So I've put these just represent 3 separate probabilities. First one doesn't take part, second one doesn't take part, third one doesn't take part. We want none of them to take part, so we want the first one not to take part, and the second one not to take part, and the third one not to take part. Okay, so you need to adapt these 3 probabilities and do a multiplication. Okay, for the next one, we need Fabio to be the only one to take part. So Fabio does take part, the next person doesn't, and the next person doesn't. So multiply 3 probabilities. Now the next one, exactly one of the 3 cyclists takes part. That means it could be, well, we've already done Fabio, so we need to do maybe something like this for Ellie and David, or is that Eli? We need to do this for each of the 3 cyclists. We've done it for Fabio, do it for the other 2 as well, and add them up to get the probability that exactly one takes part. Okay? And finally, we want either 1 or 2 of the cyclists take part. So you've got a choice here. You've just done the probability that exactly 1 does. You can do something similar to work out the probability that 2 out of 3 take part. But maybe slightly easier is to use the fact that you've done none. You know the probability that none take part. Okay. You could work out the probability that all 3 take part. So if I know the probability that none of them do, that all 3 do, could I maybe do something with those to find the probability that it must be either 1 or 2 that do? So you've got 2 possible approaches to that problem. Either one can work for you. Okay, so just work through that carefully, and I hope you'll be all right.